Hello, it's Miss Wilson. I'm coming to you from the comfort of my home office before the children wake up, and I wanted to take a few minutes to talk to you about moles. So yesterday I gave you guys half of the slideshow to go over that talked about moles, and I wanted to show you a different way to solve the problems than what was shown in the slideshow. And things are different, so if you're comfortable using what's in the slideshow, that's fine. At this point, we don't even know what it will look like to assess, but in the past, we've made sure that you guys know how to solve the problems using dimensional analysis. And the reason why we use dimensional analysis is so that we can check that we've set the problem up correctly. If you're using the molehill, if that resonated with you and the molehill works, great, that's cool. And one of the downfalls of the molehill is that there's no way to check that you have set up a problem correctly. Either you're multiplying your answers or you're dividing your answers, and there's nothing about the setup that would let you know, wait a second, I think I set this up incorrectly. Whereas if you use dimensional analysis, which is what we did probably the third day of the school year, where we had the T-charts and we were crossing out units. If a unit is not both on the top and on the bottom, and if you can't cancel it, then you know that you've set it up incorrectly. So for these problems, it can be good and reassuring to use dimensional analysis so that you know that you've set the problems up correctly. So I wanted to do a couple of the problems that were already included in the slideshow yesterday. The answers were included in the slideshow, but I want to show you how we'd set them up if we're solving them with dimensional analysis. So the first thing is when you're reading the problem, you want to look for what you are given as well as what you're solving for. And you are always going to put your given first. So that's what you are going to write with the unit so that you know what unit you're starting with. So there was a question. How many moles, or how many atoms of aluminum? Let me stop. Okay, how many grams of sulfur are in 45.67 moles? So I'm going to start doing the problems that are only one-step problems. We're only doing one mathematical, We're either multiplying or dividing. We're doing one-step problems. And then what we're going to do today is move into two-step problems. So the first question that I'm looking at said, how many grams of sulfur are in 45.67 moles of sulfur? How many grams, I'm just going to put G, of sulfur are in 45.67 moles of sulfur. So if we're looking at this problem, we have to figure out what we're given and also what we want. So our given is the thing that has both a number and a unit. 45.67 moles of sulfur has both a number and a unit. So that's what we're starting with. So I'm going to put that to the left over here, 45.67 moles of sulfur. And then I'm going to make my T-chart. I know that I'm only going to be doing one number process, so I should only need one T-chart. Now, to figure out what goes on the T-chart, I know that if I'm starting with moles of sulfur, that ultimately has to go down on the bottom of my conversion factor, moles of sulfur. So how do we know what goes in the conversion factor? Well, what goes in the conversion factor comes from the periodic table. So the periodic table tells us the weight of 1 mole of anything. So what we're going to do is look at the weight for sulfur, because that is the weight of 1 mole of sulfur. If you look up the weight of sulfur on the periodic table, 1 mole of sulfur is the same as 32.07 grams of sulfur. So this information that came from the periodic table is going to go in our conversion factor. Since we decided that moles go on the bottom and the periodic table tells us the weight of 1 mole of anything, on the bottom goes 1 mole of sulfur and on the top goes 32.07 grams of sulfur. My moles of sulfur are on the top and on the bottom, so they will cancel. And because both of my numbers are on top, I multiply them by each other. 45.67 times 32.07. And if I do that, I get roughly 1,464 grams of sulfur. And that is my final answer. Let me do one more with you. This is my daughter's easel, purchased from IKEA, and I will say this is probably the best pre-quarantine buy that we have ever made. It has kept our children busy. There's a chalkboard on the other side. So the second one is how many moles of magnesium are in 5.67 grams. All right. So we're looking for what we are given, which is 5.67 grams of magnesium. So that's going to be what we're starting with. 5.67 grams of magnesium. And we're going to make our T-chart. Since we know we have grams of magnesium on the top, we are forced to have grams of magnesium on the bottom when we solve our problem. And so to figure out what goes in this spot, we go to the periodic table to figure out how much 1 mole of magnesium weighs. 1 mole of magnesium is the same as 24.31 grams of magnesium according to the periodic table. So then you just line up your units. Grams goes on the bottom, so 24.31 will go on the bottom, and on the top goes 1 mole of magnesium. And since the question was asking us how many moles, when we solve this problem, we should have our answer in moles. So we'll cancel our grams because we have grams both on the top and on the bottom. And then since one number is on the top and the second number is on the bottom, we divide them. So 5.67 divided by 24.31, and that gives us 0.233 moles of magnesium. And that is our final answer. So I hope that if you're feeling unsure about using the molehill or knowing what number process you're supposed to use, if you're supposed to multiply or divide, using dimensional analysis may help clear that up for you. At least that's my hope. I'm going to stop this video and then I will make a second one about doing 2-step problems.